The period of a trig function is probably the most important characteristic of a trig graph that we've discussed so far. We've discussed the fact that these functions are set up as y equals a sine bx, where a is your amplitude, is the, how high does it go, what's the max of the range. B is how many complete cycles you have from 0 to 2 pi. Your period is defined as the location of where the first cycle ends. And we have a formula for period. The formula is 2 pi over b, 2 pi over your frequency. And so if you know your frequency, it's 2 pi over that. So for our very standard graph y equals sine x, your period is going to be 2 pi over b, and b is the coefficient of x. In this case, it'd be 1, so the answer is 2 pi. And this should make sense because if we look at just our standard sine graph, oh, I think I had too many x's in there. That's graphing kind of a mess. All right, so let's try that again. If we have just the sine x graph from 0 to 2 pi, remember this is one cycle from 0 to 2 pi. We have one complete wave because our frequency is 1. Our amplitude is also 1 here. But what you will notice about this is that the first cycle is that it ends at 2 pi. And because our frequency is 1, it makes, our frequency 0 to 2 pi, it makes sense that, that's the first cycle, the only cycle we have drawn here, is going to end at 2 pi. Now, for your second example here, your period is 2 pi over your frequency, or b2, which is pi. So your period is pi. And what this is telling you is where your first cycle ends. And so let's graph this. Sine 2x from 0 to 2 pi. And when we talk about where our first cycle ends, we're always talking about beginning from the origin. So on this graph here, we see, it starts here, and our first cycle ends here. Now, our frequency is 2, and we see that from the coefficient of x. We have 2 complete cycles, and we see that here. But the period is where the first cycle ends. And so we see that, we know this goes 0 to 2 pi, 0 to 360, and we got 2 cycles. That means the first one's going to be done at pi. And so our period is pi. Our frequency is 2 because we have 2 complete cycles, but the first one, it's going to end at pi, and that's what that is. And so our second or third example here, our period would be 2 pi over 1/2, and we know dividing by 1/2, we really just do times 2 over 1, and so your period is 4 pi. And when you take a look at this graph, y equals sine 1/2 x, remember from our window here is 0 to 360. And so our frequency is a half. We only have half the cycle. And so if half the cycle is complete at 2 pi, then your full cycle would need, double that. And so if half the cycle is ending at 2 pi, the full cycle would end at 4 pi. And so when your frequency is a half, your period is 4 pi. And it's the same thing for cosine. I have the graph covering this up here. It's underneath it. For here, your period would be 2 pi over 1, which is just 2 pi, because it's one complete frequency of 1 cycle is going to end at 2 pi. And just like for sine x, when your period is 2 pi, it's going to be 2 pi over 2. It's going to end at pi, and this one's going to be 4 pi again because your frequency is a half. So sine and cosine, when it comes to amplitude, frequency, and period, it doesn't really matter what the function is. The amplitude is the coefficient of the function, your frequency is the coefficient of x, and your period, where that first cycle ends, is 2 pi over your frequency.